You can hear me, no?
Oh, we can hear you. Mr.
Yes, sir.
Jairam, our chief guest is here, Dr. Sabin. And
Yes, I'm seeing Dr. Sabin. Hi.
Hello, sir. Hi.
Jairam and It is.
Yeah, okay. So we will just start. So for the students, this will be a kind of a new topic mostly. So this is something like that. Weather and climate, we will be very familiar now. So we can just see how the climate modelers or scientists or researchers making these studies basically. So that is, we may have to use some climate models. So I will be briefly mention what is this science, how we are doing this, what is this climate models, and then of course we can discuss about some research opportunities and where you can study these courses and all those things also I will try to briefly mention. So about my institute, as Shajil sir mentioned, my institute is situated in Pune, which is known as IITM, Indian Institute of Tropical Meteorology, which is a R&D institute, that is a research and development institute of Ministry of Earth Science, Government of India, working with the main motto to do the basic research in the field of ocean, atmosphere, and climate science. And basically, our main motto to improve the weather and climate service of the nation. So just like you all may be familiar that India Meteorological Department is the sole agency to give the forecast, weather forecast for the country as a whole and for its neighboring countries. So basically what we are doing is that we are developing climate models, weather models, and then we are delivering this into India Meteorological Department, and using that models or improved scientific understanding, India Meteorological Department is making their forecast. So basically we can consider IITM as a backbone of India Meteorological Department, or you can say that the weather services of the nation. Considering the importance of climate change, Ministry of Earth Science, a couple of years back, established a new center, which is called Center for Climate Change Research. That is that CCCR, Center for Climate Change Research. So which is just like a department inside the IITM. And the center is mainly set up to develop a climate model. So far means by that time, at that time, we were not having an indigenously developed climate model for the country. So the government insisted us to make a climate model, and then using that climate model, we may have to do the research and we have to make for various assessment, we have to use these climate data sets. So our main priority was to develop a climate model. So almost 3 years back, we achieved that goal and we developed a climate model. That was the first climate model developed in India. And then we started running that model and making climate outputs. So people can, anybody can download that data and use for their own research. So that was our prime goal. And then there were a lot of other requirements because greenhouse gas, you all may be familiar, the carbon dioxide, other type of greenhouse nitrogen species gases, all those things are very important, and its measurements were lacking in our country. So we took up that as also a challenge, and we are making a lot of measurements in various parts of the country. And apart from that, we have a paleoclimate modeling group and paleoclimate observation group. So, for example, something like that in a climate center, we have to know how was the monsoon before 5,000 years or so. You might have heard about medieval warm period and all those things. So at that time, how was our weather? So this type of information is also very important. So we have a very strong paleoclimate group. That is what basically happening inside the climate change center. And to support all our climate activity, climate modeling activity or weather modeling activity, we need enormous computational powers. So that means we have a dedicated computer center, and which is a supercomputer. So this picture, the top panel is the first building of our IITM, and the bottom picture that is written is CRE. That is the CRE machine. We have two machines basically. One is an IBM machine, another one is a CRE machine. So it's named as Pratyush, and this is just like you will be feeling just like a small wardrobe or something like that. So this is a parallel computing device. Basically, you can say that hundreds of CPUs are parallelly stacked with the help, and they are connected with the help of certain optical fiber cables. And using these high performance computing machine, you can quickly solve your problem. So something like that, if a single computer can solve your problem within 10 minutes, and if I am splitting this code into 10 computers, I can fastly do my job. So that is what basically a climate or weather modeler wants. So making our job faster, we have a supercomputing facility in our Pune campus. So climate science got wide attention, especially in last year. You all may be familiar that climate scientists, two of the climate scientists, Suki Manabe and Hasselmans, they received the Nobel Prize in Physics in last year. So basically, these two gentlemen you can consider as the father of climate modeling. And this Suki Manabe, he was working in Princeton University, GFDL. There is a laboratory called Geophysical Fluid Dynamics Laboratory, GFDL. So they started this climate modeling in early 60s. So basically what they did is that they developed a climate model and they started to incorporate carbon dioxide values in the model. And they noted that if you include carbon dioxide, you can see that the temperature is slightly begins to warm. So even in 1960s, they were thought about this aspect. Hasselman is basically oceanographer. So basically their contribution is open up a new field. And that's why they received all these IPCC assessment and all those things are basically following their studies and all. So that's why they received the Nobel Prize. And it was a great boost to this climate field as a whole.
Sir, I have a question.
Yeah, please.
If someone was to take, like, a lot of carbon dioxide is emitted by factories, isn't it? If someone was to take that, package it in containers, sell it, wouldn't they make profit?
Yeah, okay. I will get back to your question at the end of the talk, okay? Yeah. So, yeah. So just another important thing what happened was the IPCC 6th assessment report. So this is basically, IPCC is a UN organization. You might have familiar with the UNEP, UNICEF, and all those things. So in 1980s, basically to understand, so when this climate change came up as a major issue, World Meteorological Organization and United Nations Environmental Program jointly started a new organization which is called Intergovernmental Panel on Climate Change, popularly known as IPCC. So you can see that it's a joint venture of World Meteorological Organization, that is WMO, and United Nations Environmental Program, UNEP. And so their main idea or main focus is to address the science of climate change, or they want to assess the status of climate. How, in a present state, for example, the 6th assessment report, if you consider, the report critically assess what, using the current available data and information and model output, they just combine all this information and try to make a critical evaluation of what is the status of the climate and how the climate is going to evolve in future. So this is basically a huge effort. Basically, I was also fortunate to be part of this IPCC assessment. And we nominated in 2018. And from 2018 to 2021, we were continuously working for this report and making a lot of meetings. So many people from the world, those who are working in the field of climate and allied science, will participate in this forum. So basically, these are government nominees. From Government of India, nominate few people from here. So like that, people across the country. So these are all their own government nominees. United States will nominate their members. So like that, many people will come in a single umbrella and they will start critically assessing the climate, status of climate. So the previous reports were called 5th assessment report. And so it will take a huge amount of time. So something like that, 4 to 5 years will take to prepare one report. And before that, the 4th assessment report was also released. That was the prestigious report which got wide attention and climate change. You might have familiar that at that time, IPCC received Nobel Peace Prize in 2007. And so basically, you can just consider this report as a Bible of status of climate. And based on this report, the governments are assembled at some point, and then they will decide what should we do to tackle this issue. So there comes the importance of UNFCCC's COP meetings. Recently, it is happened in Glasgow. You all might have noted from news that our Prime Minister also visited in this COP meeting. His previous meeting happened at Spain. I was participated at that time. At that time, our Minister Prakash Javadekar was leading the team. But certain meetings are very important. So the last meeting was very important. Most of the nation premiers were participating in that meeting. So what in this meeting, again, this is a government forum, and which is coordinated by United Nations. Just like you can think about UNEP, UNICEF, like that, this is a forum which is dedicatedly working to make a framework of climate change. So how we will tackle this issue? So just think, IPCC is basically something like that. They assess all the science. The people across the world gather, and then they will assess all the science, and then government has to agree this. It means all the reviewers has to agree, all the government has to agree this report, then they will release that report. Then the world leaders, that means, if you want to implement something, the government has to intervene in this effort. So that means at that point, each government is considered as parties. So that's how the name COP, Conference of Parties. So here parties means government. So basically, the government is participating. Each and every governments in the nation under the umbrella of United Nations will meet at some point, and then they will discuss deeply what are scientists telling about the climate, the status of climate, how we have to proceed at least to tackle these issues. So this type of maybe you may be familiar that Paris Agreement, it was also very prestigious. In Paris Agreement, that was basically the COP21. So basically this will happen at every year, maybe because of this corona, and also sometime they postponed it. So basically that Paris Agreement happened in COP21. And at that time, the governments are agreed we should reduce the global warming at least within the 2-degree level. So at least for a better future, at least 1.5 degree warming, we should limit our industrial emission and all those things in such a way that the warming should not exceed 1.5 to 2 degrees Celsius in the 21st century. So that was the main essence from the Paris Agreement. Even in India also agreed to that agreement. So agreeing to these type of things has a lot of economical implication. So you may be thinking that, for example, for our electricity generation, coal is the cheapest way of, hydro may be the cheapest, but we don't have many hydroelectric electric generating options. But then we have to depend upon coal. But if you are going to green energies, at a nominal stage, the production cost will be relatively high. So that means if you want to implement green initiatives, simply you may know that the petrol bikes are comparatively cheaper than an electric bike. Maybe in future we will get at a cheaper price, but so far if you consider, so the green practices are slightly more expensive. So all these commitments need huge economical impact. So by thinking all these points, government will agree certain things. For example, in this COP26 meeting, which was happened in Glasgow, our Prime Minister made a lot of historical statement, and he mentioned that India is going to cut the total carbon emission by 1 million tons in 2030, and we will reduce the carbon intensity of the economy that is based on carbon-based economy. We will keep less than 45% by the end of this decade. And the most important statement was by 2070, we will keep the net zero carbon emission. So that means the emission and whatever we could able to absorb will be almost same by 2070. So these meetings decide all these framework, and accordingly the government will formulate their standards. So you may be thinking that how the government will implement all these things. So you know that our vehicular emission standards, we can gradually we will be upgrading. So BS stage, Bharat stage 4, Bharat stage 5, Bharat stage 6. like that we will fix our standards. So that means, but it's, if you just think about an old car which will emit a lot of carbonaceous species, or a lot of fumes will be coming from its exhaust. But now you see a new generation car's exhaust, you may not even see some traces from there. So these are some government policies making these type of emission. Then promoting the green energy initiatives. Maybe government will be promoting solar energy. Government will be promoting wind-based energy. So all these things are formulating in these type of meeting, and then each and every government will be committed to implement these steps in their nation. So that's how the governments are formulating these methods, and then they are trying to implement it at different stage. So the IPCC report mainly mentioned that the climate change is already affecting every region on the earth in some way or another way. Sometimes, some places it may be increasing temperature, some places it may be decreasing rainfall. So it can affect everyone in the world. So the recent changes, what the scientists noted is that the climate change is widespread, rapid, and its intensity also varying. And it was not, we have in our known history of time, such a changes was not visible to mankind. That was the word unprecedented in at least in thousands of years. So that means maybe in a few 1,000 years back, or if you monitor 5,000 years back, we were at a warmer stage. But at least in last thousands of years, we were never known that the temperature can go up like this, or the weather variation, the intensity of rainfall in such a way we never experienced. So one important findings in this report is that human activities are causing this climate change, or scientists are clearly saying that the man-made activities, or we can call it as anthropogenic activities, are mainly responsible for this climate change. Now let us see how we are making these type of statements, or how we can clearly say that the climate change is man-made, or in future, how we are going to make these simulations. So all those things briefly we can go through. So just to start, basically, this Earth, atmosphere, ocean science are basically the study of ocean, atmosphere, and their mutual interaction. Basically, sun is the source of energy, and it emits as shortwave radiation, and that shortwave radiation reaches at atmosphere and its surface, and it will re-radiate into different forms. The temperature will increase. You know that Earth is somewhat you can consider as a globe, and at different region, this solar insolation reaching at different rates. That means equatorial region we will be getting more energy, the polar region we will be getting less energy. That temperature difference can create a pressure imbalance. So if there is a pressure imbalance, there will be movement of air from one place to another. That is simply we call it as circulation or wind. From one place to another, it will move. So this is the larger pattern. In local level also, various things can happen. If more and more energy received at some particular point or some particular place, basically you can consider if you heat some region, let us assume our Earth atmosphere system has a lot of components. We have ocean, we have biosphere, we have geosphere, we have cryosphere, that is something related to the ice. And all these components are interconnected. So suppose just think that if solar energy reaches at ocean surface, it can initiate a lot of evaporation. So that means if wind is also favorable, that means strong wind. So you may be thinking that how ocean temperature is something like 30 or 35 degrees, then how this evaporation happened. So that wind is also responsible for that. So something like that, if you boil a water to make a tea, and if you just blow something there, then you can see that even at a lower temperature, evaporation can happen. So that is what basically a lot of evaporation will happen. That evaporation will lead to cloud formation, and then again it will move to some other place. Then some other region you will be getting rainfall. So these are basically the water cycle and this energy cycle. So all these studies mostly in this science is undertaken. So Earth, atmosphere, ocean sciences, and their interaction is widely covered in this subject. So maybe you may be thinking that weather and climate is slightly misconcepted always. weather is something like that. It's a instantaneous, what is happening instantaneously. Just like if you just through your window, if you can see outside, if it is a clear sky day, or if there is a cloud, if there is a rain, if there is cold, snow, as according to different places, instantaneously what is happening in atmosphere, that we simply termed it as weather. And how we will measure this weather is that there will be a lot of instruments. So you may be familiar about some of these instruments at least. So this one is a rain gauge, which can monitor, which can collect the water and estimate how much rain received. So then thermometer-based instruments to measure the temperature. And this is something called anemometer, which can monitor the wind speed and wind direction also we can monitor. So this is a sunshine recorder where solar insolation, how much it is, so many things related to solar insolation we can measure. So this balloon in this picture is something called radio sonde, which all the meteorological center will release from surface to the top of the atmosphere, which is appended with a small box. You can see that a small box which is having a lot of instruments, and that will give you the vertical profile of the atmosphere. Okay, so temperature, humidity. Yeah. So these are all these simple instruments you can measure the weather of a particular place. So basically, these are all the old kind of instruments. Now the latest technology, a lot of updation happen. All these instruments are automatic instruments nowadays. So automatically it will monitor. So earlier people intervention was required. Now these are all automatically instantaneously recorded, and automatically data will come to the data center. So that's how people are measuring this at each places, how the weather is. So basically, the meteorology has no boundary, because weather at a particular place can alter. For example, if a cyclone is forming over West Pacific Ocean, somewhere here, if a cyclone is forming, that can alter the weather over many regions. Sometimes a cyclone forming over this region, it can move through this side and it can reach over this side also. So the weather is don't have any boundaries. So a lot of collaboration, international collaboration is required in this field. So what in this plot, all these red dots, what is this denoted is the meteorological observatories. So like that, in India, you can see that there are many dots. So we have that much observations daily. India Meteorological Department is taking on a daily, or sometime it may be a 3-hourly, 6-hourly, or in a designated interval. So like that, you can see that China, Africa, many places you have these type of dots. In America, you can just see it just looks like a red shade. That means they have that much intense network they have. So that means if you are getting more and more observation, your forecast and your understanding and your prediction will be more and more accurate. So you can see that Japan, Europe, America, all the developing countries, they can manage a lot of observations. That means that much investment may be required. So that means slowly we are developing countries, so we are also increasing the network to get more and more data. So in addition to that, you can see that the bottom one is ocean observation. So you may be thinking that how we are measuring oceans. So all these red dots in the ocean, that is in the bottom panel, this panel, if you concentrate, all these red dots are permanent observatories. So that means there will be, we can, just like if you are anchoring a ship, like that you can anchor some instruments there. That is called buoys. Buoys will be anchored there, so that they are a kind of permanent things, which is giving you which is collecting all the ocean bottom information, and at nearby atmosphere information also it is collecting, and it is transferring through the satellite, and you will be receiving at a receiving center. All that blue dots is called Argo Float. That was a major development happened after 2010. And what it is doing is that you are just deploying a device. It will be just like you all may be familiar with the pump, the pump which you are immersing in a bore well. That is just like a long tube. So this device you can just imagine like that, and you are deploying somewhere in the ocean. For example, this is also a collective program. We have an institute which is working in this Andhra region. So that institute deploy a lot of these Argo floats in our nearby oceans. But you know that oceans are always moving from water will be moving from one place to another. So that will drift somewhere. So once if you deploy it, after some time it will reach in Southern Ocean. It can go to somewhere. It can go to other side. But what it will be doing is that at certain time it is programmed in such a way that at a certain time it will go down to the ocean and make all the measurements, and then it will come back at certain time. And then at that time, when it reaches the surface, it will again monitor certain things. And then at that time, it will transfer all the collected information to satellite. And then the receiving sender will receive its data and use for various purposes. So these are all the two senders you have to be keep in your mind: Met observation and ocean observation. Then now, after 1980s, a lot of satellite developments happen, and now we are getting huge amount of observation from space-borne measurements. So ISRO has a lot of support to Indian Meteorological Department, a lot of INSAT series satellite you may be familiar. So basically, they are taking the brightness temperature. They are measuring the brightness temperature. So brightness temperature is something like that. If you are taking a photograph, you can see that wherever the maximum reflection is there you can assume there will be clouds. So like that, using some simple physical principle, you are making an estimate of the clouds, and then you can consider you can use these for weather forecast and all those things. So nowadays, using all these weather instruments, using satellite instruments, you are incorporating all this information and trying to make weather prediction and to run the weather model or climate model. So this is so far we just discussed about weather, which is what is the current state, instantaneously what is happening. So now we can just start to think about climate. A climate is something, is an average weather condition of a particular place. So that means we all know that the Kerala receives a huge amount of rainfall from 4 months, from June, July, August, and September. So we call it as monsoon months. So we all know that is always happening. That means every year that the same phenomena will be recurring. So we can say that at that time, this monsoon type of climate prevailing over Kerala. So like that, mostly tropical regions will get more rainfall and more temperature. So accordingly, we will classify the different region. And other factor which can control the climate of a particular place is where our latitudinal position. For example, you all are familiar that Middle East region, they are all desert regions. So basically that is subsidence zone. So that means the weather development is not, if something has to happen, means some weather development happen, means you have a vertical motion should be there. Okay. So if vertical motion, that means moisture can go up, it can lead to cloud formation. But if there is no vertical motion, or for from some region, if there is a subsidence is getting more, then that region weather development is almost impossible. That type of regions are converting into desert. So that means where your latitudinal position in a globe. So if you think about a globe and where India is located, that region is very, very important, because you can otherwise you just think about England, UK, Europe. That region is much north of the equator. So then they will be getting a different types of climate. If you are going further north, something towards Norway or Russia or somewhere, Alaska, so they are getting a different kind of weather. So where you are located, that is also very important. And your altitude, something like if you think Munnar is a hill station. The weather, the climate, what Munnar people experiencing and the people experiencing at the weather at Cochin are entirely different. So like that, altitude can create a lot of difference. And another example is mountain barrier. So you all familiar about our Western Ghats. So Western Ghat is something like a barrier. Suppose wind is coming from this ocean region towards this barrier, and those who are in the, we call it as leeward side. For example, you can just imagine Kerala, and towards one side we have ocean, and the other side we have this Western Ghat mountain. So if something is blocking, the further air movement will be blocked. So something like that, you will be receiving more rain in this Western Ghat side. But you think about the other side, the Tamil Nadu side, they will be experiencing dry climate during the monsoon season. So that means simply air is not much moving towards that region, and they are experiencing slightly, they may not get enough rain during the monsoon season. So that means a mountain barrier can create a lot of change in the climate, what you are experiencing. And another possible option is that the presence of water bodies. You all know that near the coastal region, you may be experiencing some other type of climate, but in a hilly region, you may be experiencing something different. Near the coastal region, a lot of evaporation will be possible, and a lot of moisture will be available, a lot of cloud formation. So even in thunder shower of activity will be relatively more over that region. So where is your latitudinal position, altitudinal position? What is the geological condition? Where is your location? All those things are very, very important in terms of general climate. So you can just see this is a global surface temperature map. This is an annual average map. This is a recreated map from all the observation, incorporated satellite information, but I mentioned that ocean observation, all those things are considered in this map, where you can see that this is given in Kelvin. So you have to take the difference to convert it into degree centigrade. So generally you can see that the dark maroonish or dark reddish shades are the regions where having more temperature, whereas in the polar region you can see that the bluish shaded regions you will be getting very less temperature, means relatively colder temperature, and the equatorial region will be relatively warmer temperature. This can have seasonal variation also. We know that during March, April, May season, we will be getting the temperature will be very, very high. But now in the winter season, December, January, February, over India, if you focus, the temperature will be relatively less. So this is given in degrees Celsius. You can see if you compare this temperature, the 30 is something around 20 here, 20 degrees centigrade. But if you see the top panel is for the November, December months, and the bottom panel is for the May, June months. So upper you can consider it as winter months mean temperature. The lower panel you can just think about just like how much the global temperature during the month of summer month. So this is just happening. Just think that the position of the sun. You will be familiar that during the northern hemispheric summer, the position of the sun will be slightly towards the northern hemisphere, just because of the Earth's shape and its tilt. So you will be getting more insolation here. But in the southern hemispheric summer, that is winter season, in our winter season, you can see that Australia, the southern side, will be having maximum temperature. But in northern hemispheric summer, you can just see the African region, Middle East region, northern India, we are getting very high temperature, that is temperature more than 34 or 40 degrees centigrade, it will be reaching. So like that, the rainfall, since this temperature belt is also changing, so like that, there will be seasonal variation in rainfall also. You all may be knowing that nowadays we are not getting much rainfall. So that's why here it is white shade. White shade means almost there is no rain. So this is the winter season, again in the top panel. The lower panel, you can say that this is JJA, means June, July, and August months. That is, you are very familiar that that is our monsoon season. Here you can see that during the monsoon time, you are getting maximum amount of rainfall over this Western Ghat region, over this Central Indian region. We are getting huge amount of rainfall. So this purple color means you are getting more rainfall. This bluish or greenish shade means you are getting very less rainfall. So you have to just keep in your mind that there are a lot of seasonality also there in this temperature, rainfall, and wind, and all other patterns. So now just we can slightly move to, so now you got an idea about what is weather, which is something instantaneously happening. What is climate? So what we are feeling over a particular place, this type of weather we are experiencing for a long time, that we termed as, that is the climate. So now, sorry. So now we can just move to climate change. So we, yeah, sorry. So this is something like that. You got a picture that climate is something like that long-term average of weather. So we are experiencing a monsoon type climate, and now we are just trying to see that whether in a long time scale, in a 30-year or 40-year or 50-year time scale or a 100-year time scale, are we experiencing some change? It can be for anything. It can be for temperature. It can be for rainfall. It can be for number of cyclones you are receiving. So anything. It can be sometimes at some places it can be for snowfall. So for any these type of weather patterns, if you are experienced, you are just trying to examine whether I'm getting the same type of temperature what I received in last year or 10 years back or 50 years back. So at that point, the term climate change is coming into picture. And global warming is something which is very familiar. If the temperature is increasing, we can simply refer it as global warming. So don't think that all the parameters may increase. Sometimes rainfall, it can decrease also. That can also we consider it as climate change. For temperature also, it can be similar. It's not uniformly warming. If you consider the globe as a whole, some places temperature may be increasing, some places temperature may be decreasing. Rainfall also like that. Some places rainfall may be increasing, some places rainfall may be decreasing. But altogether, what will be happening? That's what we will be trying to examine. So just like normally scientists and researchers believe only in data. So something like that, what you may be feeling may be something different. You maybe feel that, oh, I am getting warming, so this is due to climate change. But nobody is going to take that your word, because science should be driven or proved using data. So for example, so if you want to study something like that, is the temperature over Calicut is increasing or not? So what you have to do is that you may have to collect as much as possible data set. So for example, for the India Meteorological Department has the data from almost nearly last 100 years record they have for the major stations. So you have to simply do is that you have to approach the India Meteorological Department and you have to collect the data. And what you have to do is that you have to simply plot every year. You have to make a value. It will be daily value. Then that you have to convert into annual average. So that means you will be getting, okay, this year's mean temperature is this much. That one quantity you got. Then what you are doing, you are taking next year how much temperature, next year how much temperature. So this you can do in multiple way. In the month of, for example, now we are in the month of February. So February, what was the mean temperature? That value you are taking. Then next year February, what was the value that you are taking? So like that. Suppose if you have a 100-year record, you will be just taking this data set and just trying to plot. So that's what plotted here. Here, what I plotted is that, so like that, what I mentioned is that in Calicut, which is a spot over this region, and you are just taking something and you are just trying to plot, okay, this temperature data. So if you are seeing something like this is your X and Y maybe. So if you are getting some pattern like this, okay, you can clearly say that, oh, the temperature over Calicut is increasing. That you can clearly say. So some places it may be decreasing. It may be decreasing. So you can say that, okay, temperature over that place is increasing. Some places there may not be much change. There will be some variations like this, like this, like this, like this, like this. It may be going. So you can say that, okay, even maybe I may be experiencing hot weather, but using data, there is not much change is experienced or not much change is experienced. That also you have to believe. So like this. So now we just described about Calicut. So like that, as I mentioned earlier, we have the data, all the meteorological centers collected the data for the past 100 or 120 years. So if you average all those available data, you will be getting the temperature, mean temperature of the Earth. So that means all the available data you are taking and you are making a time series, and then you are just plotting this. So this is what I mentioned. So you can see that there is a clear increasing signal. So that is what plotted here. So here you may be seeing that this 0 value and there is a minus and 5. So this is in normally the temperature data or anything what we plot based on certain reference period. So here the reference period is somewhat here. So something like that. If the temperature you may be measuring like that, 30, 31, 32, up to 40 you measured. Just imagine. And now you have a mean value. 30 to 40, if you keep, your mean value will be somewhere 35. So if you subtract that 35 from your each value, your initial value was 30 become minus 5, correct? Minus 5, minus 4, minus 3, minus 2, 0. So that was where you took the mean. And then it was 1, 2, 3, 4, 5. So that we generally call it as anomaly. That is variation with respect to a particular place. So that's why don't think that temperature was negative at that time. So this is relative to this temperature period. The temperature was cooler, and after that the temperature was warming. So roughly we can say that the global mean temperature is increasing. So here I just keep an animation which is from 1850 to till day. Here you can see that the bluish shades are negative. Again, it is relative anomaly. The temperature was less. So here my mean is with respect to 1950. So what it is displaying is that with respect to 1950 temperature, how was the temperature in 1891, 95, 96? And then it will be showing with respect to 1950 how the temperature presently how it is. So now mostly you can just visually you may be familiar that seeing that the bluish shades are temperature was less, and now you can see that if it is crossing 1950 or 1980, mostly it will be the map will be reddish. Red color means the temperature is more. Bluish is temperature is less, and the reddish temperature is more. So it is 1969, 1972. You may be familiar, seeing that more and more yellowish and reddish shades now. After 1980, 1991, 96, 97. Now your map is mostly yellowish shade. Now it is mostly reddish shade. You can see that 15, 16, 17, 18 like that. So you maybe got a visual understanding, I feel. So you can visually you can see that it was we were in a much cooler state, and now something is some changes happened, and we reached in a warmer state. So that is just represented in this map. So for preparing this map, what we used is that, so this is all the available observed temperature records are used, and then we took a reference period, and with respect to that reference period, how the temperatures are varied. So if you see the mean 2020 temperature and 1900 temperature, there will be huge difference will be there. So that what we refer to as climate change, or you can see that global warming, or if you make an average of that temperature, it will be something like 1 degree Celsius warming. More than 1 degree Celsius warming you can experience. So this is again that anomaly. This is a global mean temperature. With respect to this time, temperature was much lower in 1870, and with respect to this time, temperature was much higher in 2020s. This is 2020, and the temperature was very high, and this value was reached almost 1 degree centigrade. So that we generally discussed as comparing to the pre-industrial period, the global mean temperature is increased, and or simply we can say that warmed by almost 1 degree centigrade. So this type of information you can see in many fields. So far what we discussed was in temperature. So this is a sea level monitored from satellite. You can see that sea level over a particular place, over a particular place for 10 years, it seems to be increasing. Yeah, it seems to be increasing. Here, if you took the value, it was like this, and if you took the value, it was 40. So this is just for a 10-year period. And if you took for a long period, you can see that the sea level is also increasing. So sea level increase maybe can be happen in two ways. It can be due to thermal expansion. You know that if some temperature is increasing, air and water, it can expand. So that is called thermal expansion. And it can in other way, it can happen due to a lot of land ice is melting. That can also increase the ocean volume of ocean water. So these two ways, the sea level rise can happen. So something like this, if you take the rainfall information, you will be seeing some change. So all these type of information you can connect. And IPCC 6 assessment report simply mentions that if you consider the temperature-related extremes, so this is a schematic representation of our globe. So we will be somewhere here, this South SAS, that is South Asian region. This is Africa, and this is South America and North America. I hope you got a clear idea. So what the red sign indicate means red is increasing. So that means all over this globe, the temperature-related extreme temperature events seems to be increasing. So now we can just see why is this global warming happening. So it can be two reasons. One can be natural cause, and other can be anthropogenic reason. Anthropogenic is something like that, man-made reasons. So there can be, why we want to study this natural reason, because we all know that in prehistoric time, many things were happening. We were at Ice Age, then we were at a very warm, medieval warm period. Then the temperature was cooled down. So many things were happening in long time back also. So we have to examine, is it a natural factors are responsible for this climate change? Then we have to clearly say that if it is not, is there any anthropogenic or man-made reason behind this? So these things we have to see. First of all, I will just discuss about what are the natural things which can alter our climate. So one possible thing is that you may be in your schools might have heard about Milankovitch cycle. So Earth has an elliptical orbit around the sun. So, but these type of, so if you come close to sun, you will be getting, naturally you'll be getting more energy. If you are far away from sun, you will be getting very less energy. So, but these type of changes will happen in a 20,000 or 100,000 year time scale. So that factor we can eliminate. So another possible thing is that if you are interested in sunspot activity and or solar cycle, you might have heard that sun has a 11-year cycle, something like that. It's increasing. Solar activity will be more at this point. Then it will be less, and then it will be increasing again. It will be decreasing, but it's more or less similar. There was not much change. It's not increasing or not decreasing. Then other factor is that volcanic emission. You might have heard recently also there was a volcanic emission. If a volcanic emission happen, it can pump huge amount of aerosol. We call that as aerosol. These are all tiny particles, small, just to imagine dust or some black volcanic ashes-like substance is spreading into the atmosphere. From a volcano, huge amount of tons and tons of carbonaceous substance and these type of aerosol, that means small particle can pump into the atmosphere. If it is spread like a blanket over the atmosphere, just imagine over a big region you have a blanket. So just like we have some pandal or something you are keeping, and that just imagine as a blanket over the Earth atmosphere. So naturally, what will happen? Solar radiation, it will reflect from that. According to the property of the aerosol species, mostly they are all having sulfate aerosol. There are many species of aerosol, but in general, you can call that they have more reflective property. So it will reflect that solar radiation. So that means that from the top of the atmosphere, from the atmosphere, it will reflect back. So that means the solar radiation penetrating towards Earth will be, or Earth surface will be, surface of the Earth will be relatively less. So naturally, what will happen? That region will cool. So basically, aerosol and related things can cool the atmosphere. So these are all the natural factors which are playing major roles in our climate system. And then another things are anthropogenic factors. The main anthropogenic changes what we made is that land use, land cover changes. We know that before when the population explosion happened, lot of forest area we converted into crop area or residential area or industrial area we converted. So this can create huge change in reflectivity of the surface. So again, everything is connected with solar radiation and how it is reflecting back. So you know that the white and black substance, how it will reflect and how it will absorb. And in between also, according to the spectrum, it will absorb and it will reflect. So these changes in the land use, land cover change can also make huge difference in our climate system. So then the most important culprit is coming in picture is the fossil fuels. So it can be from industrial emission for a lot of factories are producing a lot of carbonaceous aerosol, nitrogenous components, and electricity generation. This also required a lot of fuels. Then of course our transportation also producing a lot of carbon dioxide. So these will produce a lot of greenhouse gas into the atmosphere. So basically, if you make an observation, this is from 1960, the carbon dioxide concentration in the atmosphere was 320 ppm. This unit is parts per million. Just forget that values, just that ppm unit, but just keep the number. In 1960, value was 320 ppm, and presently 2020, the value is more than 412 ppm, or nearly it is going to touch 420 ppm. So that much changes happen, at least in, if you consider a 40 plus 20, 60 year time period, this much huge changes happen. So this is a clear sort of sign of increasing signal what you can observe. And if you consider the value of 1850, that is mostly these carbonaceous species, carbon dioxide, greenhouse gas, and all those things are a byproduct of industrial revolution. So if you, for a reference period, if you see the pre-industrial revolution in America, Europe, industrial revolution happened long back. So if you see the 1850 values, 1850, how much was the carbon dioxide value? If you took, the value was something 280 ppm, and presently if you compare with the 412, if you take simply how much percentage this will be, you can see that almost 49% increase. Actually, you can say that 50% increase in this greenhouse gas concentration or carbon dioxide concentration happened in the atmosphere. So that can have a serious implication in our climate system. So there are, this carbon dioxide is the most important. So if these are a simple schematic map showing the other type of greenhouse gases also. It can be carbon dioxide, and it can be methane, it can be other gases, nitraceous species, fluorogen-based species. There are many carbonaceous gases are there. Sorry, greenhouse gases are there. But carbon dioxide are the most contribution. You can see that 64% is contributing by carbon dioxide. So that's why we are mostly discussing about carbon dioxide. But from the word greenhouse gas, just keep in your mind that there are many greenhouse gases which cause this type of adverse effect. And this is a simple map. Who is producing this much carbon dioxide? You can see that mostly the developing countries. You can think that they will be having a lot of industries, a lot of vehicles, so their emission will be huge. So basically, United States, USA is producing more carbon dioxide so far.
Where is India?
India is here only. Are you able to see?
Wow, that's a big difference.
Yeah, there is a big difference, almost 10 times less than what US is producing. China is somewhere here. You can see that 13.9% is their contribution. So basically, you can see that
we have the most population density.
Germany is very small country compared to India.
Yes, but their production is so high. You know that lot of
we have high population, but still we are only getting this much. It's
yes,
amazing.
That is true. That is a good sign. But still, we have to try to reduce it. That's the thing. Japan, you see this value 3.9. Japan, because they have
Japan is so small.
Yes, small country, so less people, but their industrial production is too high. They are selling cars to the entire world. Toyota, all their cars are everywhere, so they have to produce it from there. So that will create a lot of industrial emission. That's what they basically. So basically, you can just keep these figures in your mind. United States, China, Russia. There are a lot of countries are there, but if you divide by per capita, we will be nowhere. But then this case will be per capita production will be very high. But still, just you can relate this thing in your mind.
But there is no Oceania countries.
This is not all countries. This is just a few countries only. So if you take 150 or 200 countries, that is small countries. Small countries, they took in a same single. That's why this is coming. Okay, you may be referring this now. Is it clear? The small island countries.
So there is 4 Asia, 1 American, and
Eurasian countries like that.
1 Eurasian.
Yeah, this is
Wait,
not
no, 3 American. 3 American.
What I want to tell you that this is not a complete list. So there is it's a long list. So if you add together, that will be a different chart. Okay. So there are multiple charts. So this is from just focus on this number. This is from a country representation. So they have a different in other European countries also they keep in a same color. So that's why this is coming, and that's why the confusion. Okay, hope it is clear. Yeah. So basically, we were considering this greenhouse gas as a villain, but mostly you all know that the greenhouse gas is a blessing for Earth. That's make the life possible in our planet. Because if you compute the solar energy and what we're receiving is that. And using one equation, there is some equation called Stefan-Boltzmann law, and that is connecting temperature and this how much if you consider basically you can just keep using that equation. You can estimate the temperature of the Earth. So basically, if you compute the temperature of the Earth, our temperature will be much less than 0. It will be something like minus 18 degrees centigrade or something, minus 18. So, but just because we have a layer of these greenhouse gases, what is happening is that, so this solar radiation, which is coming from a hotter planet, it's shortwave radiation. So just like the equation what I mentioned is that it's an inverse relation of wavelength and temperature. If it is temperature is small, wavelength will be small. But when it is reaching at the surface, Earth is a cooler planet, so Earth will emit as a long wave radiation. Okay, it will be a long wave. So once this long wave reached the atmosphere, okay, so since it is while coming, it was a smaller. While coming, it was a smaller short wave, a small waves, and it can penetrate. It can penetrate through this substance, and it can reach surface. But while going back from the surface, it's long wave. So basically, if it is long wave, it will block here. So this you consider as a greenhouse gas, it will block there. If it is blocking, then what can happen? Partially, it can absorb there, or it will come back to Earth, and again it will re-radiate like that. So this process will happen multiple times. So that is basically making from a minus 18 to this Earth's temperature to a plus 14 or plus 15 what we are experiencing now. So plus 14 means average temperature of Earth. Okay, it will have a lot of variation. India, it will have different. Europe, it will have different temperature. It will have seasonal variation. But on an average, I'm telling, from a minus 18, if there is no atmosphere, the temperature would have been much cooler, and life would have been almost impossible in our Earth. But just because of the presence of this greenhouse gas, so actually greenhouse gas, you have to love greenhouse gases. Greenhouse gas was a blessing. Okay, so that is the only factor which is keeping the Earth's temperature a livable condition. Okay, plus 15 or plus 14. So that is a greenhouse gas was a blessing so far. But now what happened? So what will be happening is something like that. This is just like you all might have studied the greenhouse effect and all those things. What is happening in a polycarbonated house for the nurseries to grow the plants. So Earth as a whole, if you consider as a blanket of greenhouse gases we have, that's what this schematic means. And that is trapped inside. This short wave is coming, long wave is going. So at this level, it is coming back. So this is happening at a multiple times, and that will keep the Earth's temperature in an optimal level of 14 or 15 degrees centigrade. Life is almost possible here. So, but what happened due to lot of this the man-made interventions in this natural balance make this issue make this something may create a lot of imbalance. And that's creating a lot of perturbation, and that's why this greenhouse gases and all those things are increasing. So if this greenhouse gas increasing means simply what will happen, more and more energy will be trapped here, and the temperature will be more and more increased. So naturally you can experience, if it is more greenhouse gases, more energy will be trapped inside the Earth and Earth atmosphere. Naturally, the surface air temperature will warm, and that's what we are able to experience. Something like that, a 1 degree warming, that's what we discussed earlier.
Wait, sir.
Yes.
If you were to use something that uses heat to produce energy, then continually using the greenhouse energy to eliminate the greenhouse energy, stuff like that. Using the heat.
Thank you. I tell you.
That was rude.
So what I just yeah. So what I guess from your question is that you are trying to tell that if it is more greenhouse gas, if you remove greenhouse gas, whether we will be able to reduce the temperature. Is it that, or you are trying to say that some simple heat, whether it is converted into whether it will contribute to global warming? Which one was your question? Okay. Yeah. Okay. Keep the question. We will discuss at the end. Okay. Yeah. So simply that what responsible for this 1 degree or more than 1 degree temperature rise, what we experienced so far. So now, how can we understand these changes? So first thing, as I mentioned, that just like we mentioned, if you want to study the temperature rise over Calicut, we have to take the data and then we have to analyze. That is one option. And what is another option? Suppose, especially, how to study the changes in future. For example, future, you don't have any data. If you want to see 2100, what is going to happen? 2050, what is going to happen? Then there is you don't have any data. So you have to rely on climate models. So there, these climate models are coming in picture. So basically, the climate models are computer-based mathematical formulation, so which can recreate the physical, chemical, and or many other processes in the Earth atmosphere system. So earlier we mentioned what are all the Earth atmosphere processes. Solar energy is there, Earth is there, lithosphere is there, and then we have ocean is there, cryosphere, biosphere. All these interactions, basically all these things are, then air is there. So all these things are fluid only. So all these fluid motions, mathematically how you are governing using certain equations, and then you are trying to solve using high performance computing machines. That is what is basically climate models are. So basically you have to think it as these are all mathematical equations and we are trying to solve. So basically if you think in a simple way, we have Kerala coast. Kerala, you are getting rainfall. Most of the moisture, you might have noted that clouds will be moving from ocean side towards our land side during the monsoon season. So something like that, some moisture is available over the ocean region, and it's moving from one place to another. So simply what it is that it's simply equation of motion it has to apply. So that means just like if you are taking a vehicle from one place to another, like that, it's simply the motion. Some fluid motion is happening from one place to another. So what you have to imply is that if you want to calculate how much moisture is coming from one place to another, you may have to depend upon equation of motion only. So that's what we represented in most of the climate models. Then another thing is that temperature is there, evaporation is happening. So that means temperature is related. So that what we call it as energy equation or thermodynamic energy equation. So thermodynamics is coming into picture. So moving this something moisture or whatever it is, or wind or something from one place is moving to another place. So that is simply motion and equation of motion. In ocean and atmosphere, basically these two are fluids. So we have to use the equation of motion as a governing equation. So basically what we do is that all these equations, so what denoted here is represented, basically the simple equation of motion represented in the form of partial derivatives. Maybe you will study these things in your +2 class onwards. So using, we will convert this equation in partial differential formats. Then using computer codes, we will try to solve these equations. That's what simply a computer model will be. So in order to solve something, what you may have to want, so you have to, in this case, we are trying to solve all these equations over a globe. Okay, just imagine a globe in your mind. We have latitudes and longitudes. You are familiar with latitudes and longitude. That's what these lines in this map, these lines, latitude and longitude lines you can see. Okay, so in order to solve something, I have a set of equation over a particular, for example, I have set of equation over this point. So I have to solve this equation each and every points in this over this globe, because it's everywhere. It will be same. Movement of parcel will be same from one position to another. It's connected. This may be coming from this place, and this will be reaching here. Then it will be moving towards here, or sometimes from here it can come this way like this. So everywhere I have to solve my equation. So that is make these things are complex in nature. So not only that. So far we were discussed about surface. So atmosphere is not only surface. From the Earth's surface, it is going till top of the atmosphere. So the entire vertical column you have to solve. So that's what just denoted this structure. Or in the lower panel, you can see that from the surface up to the top of the atmosphere, you have to make this computation. So what we will do, just like this horizontally, you make a small section. Vertically also, you will be making small layers of atmosphere. So not over. So we have ocean. So far we discussed about only atmosphere. but we have bottom ocean also is there. So from surface to the bottom of the ocean, this also we have to solve. So this also at each level you have to solve. So all these governing equation, not only this one, all the governing equations you have to solve at each and every point, starting from the surface of Earth till the top of the atmosphere, starting from the ocean, top of the ocean till the bottom of the ocean. You have to solve all these things, and then you will be getting something. Okay. So in order to solve something, you need so just to its magnitude, if you want to keep in mind. So basically, you may be familiar with C programming, MATLAB programming, all those things you might have heard. Python, all those things.
Yes, I know Python.
Yeah, so you might have heard. So any software we can use to write climate code. So just like you have an equation, you are solving in any known language. Okay? So mostly the scientific softwares are very old softwares. At that time, we were using Fortran. That is a scientific language. Fortran. In higher class, you will be heard that basic Fortran, all those things you will come to later in your +2 standards time or something like that. But mostly just keep in mind that any language we have written this code, then if you take a printout of that page, it will something have 18,000 pages or something like that. So you can imagine how much codes, routines will be there in this process. Then in order to solve that, you have to use the high performance computing powers. So just I will just tell one more thing. There are different types of model. So if you are interested only in atmospheric studies, so something like that, some people may not be interested in ocean. So suppose I'm just interested in to make studies of atmosphere. I can use only atmospheric model. It's called atmospheric general circulation model. So what it is doing, it is having a set of equations to solve all the processes in the atmosphere. There are second model, which is called ocean general circulation model, which is only solving the equations at the ocean. Okay, if an oceanographer, if he is just like that Nobel laureate I mentioned, the oceanographer, he might have only interested in ocean studies. So he might have used an ocean model. The atmospheric scientist, he might have only used an atmospheric general circulation model. So these are all the different types of model. So, but we know that these are all a coupled process. What is called is coupled process are something one or more than two components are involved. So just imagine, ocean is very important for our monsoon because moisture is coming mostly from ocean. Any weather processes, mostly the suppose a cloud is developing, from where you will be getting moisture, it will be from ocean. So in a model, if you can solve the oceanic process and atmospheric processes together, you can call it as a coupled model. So that means the model 1 and model 2, you join together using some technique, you join together. So that means it will interact each other. Atmosphere will compute something and it will give to ocean. Ocean will compute something and it will give back to, just like a flip-flop oscillation. So it will give something and then it will take something, then it will go on its computation. That is called coupled model. And in your era, there are many components. It's a chemistry model, it's land model. So a lot of models are incorporated, and that's what we call it as coupled model. In some others, all these 1, 2, and 3 models are completely global. Entire globe you have to resolve. Suppose the fourth one is mentioned as regional model. Say I'm in India. I don't bother about anywhere else. I just want to compute something over India only. So at that time, what I can use, I can rely on a regional model. So that means my domain will be only over India, and only over India only I will be solving. So these type of different models are there. Just keep this as a brief idea in your mind. There are atmospheric only model, there are ocean only model. If you club these things together, it can be called coupled model. And if you are not interested, all these 1, 2, 3 models are global model. So if you are not interested on global studies, if you are interested only over a smaller region, we can rely on regional models. So if you want to solve something, just like y is equal to mx plus c, if you know the slope, then you will be able to get your next value. So, but you need that y-intercept value also, correct? If you want to get that value, if you know the y-intercept, you can exactly predict the next value. Like that, in order to start the model, you need some first guess value. Okay, to solve our partial differential equation, the first guess value is basically coming from this meteorological observation. From the current point, we will be feeding into the model, and then that model will be solved that equation, and then we will be getting at next time what will be happening. That is what happening in a model. So just all these meteorological oceanographic observation, we are keeping as a starting point for the climate model. That is, we call it as initial condition for the model. So something like that, your code know what is the present condition. And from there, you have the equation, say equation of motion. So from you got a starting value, and next at each grid point, you know something. And then, you know, suppose if the pressure is varying, your equation will be able to guide at the next time the air movement, where it can move, what will be the temperature. So all those things you will be able to predict, or you will be able to get from this climate model, so that, or weather model. So that is what this weather model is basically doing. So basically, if you build a model, then what you will do? First, you have to validate the model, or whether the temperature is coming correctly in this model. So all those things we will verify, whether the rainfall. For example, if you create a model, and if you are getting rainfall during winter over India, suppose you developed a model and you are getting rainfall over this region, huge amount of rainfall if you are getting during winter season, can you believe that model? No, correct? So we should not get a huge amount of rainfall here. That we call it as, we will compare with the observation. That is the only thing. If you made something, what you will do, you will test it. So this is something called testing. We will test our model with the non-observation, and then we will get, okay, your model is not bad, it's doing a good job. Then what we will do is that, okay, we will start some analysis based on that model. So basically, this is the first, you have to develop the model, then you have to validate the model. You have to see whether the wind pattern and all those things are properly coming. Then ocean, if you have an oceanic components, you might have familiar with El Nino, La Nina, all those things. So whether these El Nino type of phenomena are happening in ocean. So all these type of things you will be simply validating in the model. And if everything is coming okay, I'm done my job, I'm just, we can freeze the development, and then we can use for some studies. Okay, so now you just imagine that we developed the model, and then we have a computer, and we have initial condition to run the model, basic data to run the model. So then what will happen? Then now we have to understand some science point. So one thing you have to keep in mind is that this weather model and climate model, both are mostly same. The equations are same, everything is same. But there are certain basic difference in that model. In a weather model, you all know that weather is something happening instantaneously. So in a weather model, or in TV and in your media, in press releases, what India Meteorological Department is giving is that tomorrow what is going to happen, or if a cyclone is forming over that region, next 24 hour or 48 hour, what is going to happen. So in a weather model, the time limit is maximum a few days to weeks. Okay, you are not at all interested what is going to happen next year, or what is going to happen 10 years later or 100 years later. But a climate modeler is something interested on a long-term changes. In 10 years, what is going to happen? In 50 years, what is going to happen? In 100 years, what is going to happen? There comes certain other elements called climate drivers. So we are noted that aerosols and greenhouse gases are two major players. So using a lot of studies, through a lot of research, scientific understandings, people came to know that aerosols and greenhouse gases are two major players. Okay, so this greenhouse gas is something like that which warms the atmosphere. Aerosol, already I mentioned you that these are small tiny particles in the atmosphere, which is, you can imagine like a blanket over the earth. And if a big blanket you kept at atmosphere somewhere, naturally the solar radiation will, whatever coming down will be less. And if solar radiation is less, means what is going to happen? It will be you are naturally cool the surface. So just keep in your mind that aerosol is something which is cools the atmosphere, and the greenhouse gas is something like which is warm the atmosphere. So in a climate model, what we will be doing is that in addition to this initial condition, we will be properly incorporating these all elements. That is, we call it as climate drivers. All these elements are important. Ozone is important. Clouds itself can create some, but clouds is an internal factor, so it will compute itself and it will interact also it will. All these factors we have to incorporate in the model. Then accordingly, the model computation will modify how the solar radiation, coming solar radiation transform into different sectors. For example, if greenhouse gas is more, what will happen? Naturally, your greenhouse effect will be increasing, so your temperature will be increasing. For example, you are putting more aerosol in the model. The incoming shortwave radiation will be less. The energy reaching at the surface will be less. So naturally, your temperature will be cooling. And it's not only affecting temperature. For example, if you are getting more greenhouse gases, what will happen? Naturally, your temperature will increase. If temperature is increasing, what can happen? It can create more evaporation. So you will be getting more amount of rainfall. In aerosol, just think about the other case, this aerosol case. You are increasing more and more aerosol in the atmosphere. What will happen? Your temperature will reduce. If temperature reduce, evaporation will reduce. If evaporation reduce, cloud formation will be less. If less cloud formation, naturally your rainfall will be less. So these are called climate drivers. We have to incorporate somehow or other way into the climate model, and then you will be making the execution. So at that time only, you will be getting these type of answers. What will happen if the greenhouse gas is included in the model? What is going to happen? If the greenhouse gas is, if the aerosol is included, what is going to happen? So just before doing any type of science research, you have to pose certain questions. So we can say that, can we clearly say that climate change is man-made? For that, we may have to design some experiment. So then second question, how can we understand the role of natural variation? For that also, what you have to do, you have to design a particular experiment. So now the third question and most important is that how can we study the future climate? So you may have to find out some solution. So that means here solution is that in climate model, what you are going to do. So there mostly the importance of these international bodies, IPCC, there is World Meteorological Organization have a different program called World Climate Research Program. So they design all these data sets. For example, greenhouse gases, aerosol, all these data sets using different techniques they will develop it and they will make available for researchers across the world. So for example, IITM in CCCR, we are running the model. So we will take these data from this center, an American institute. So they will be also taking the data from the same source. And European institute, they also will be taking, and Chinese institute, they will be taking from the same source and making the data. So what is possible if everybody is using the same data set to start the model, and intercomparison is possible. So that is something good. Everyone is taking from one source, so there will not be difference. Otherwise, we may have to debate on that. So somebody will say that the greenhouse gas you used is not correct. So there can be, that debate can go into some other direction. But here, everyone is taking the same data set source and then making the simulation. So there will be, so keeping all these three questions in mind, there will be different experiments. So I'm not going much detail into this experiment. There will be something called, if you want to just see this experiment number 3, this is mentioned aerosol only experiment. Here you just keep in your mind that here as a climate driver in your model, you have only aerosols only. Okay. The experiment number 4, you just keep in your mind, this written as greenhouse gas only experiment. So here, naturally, you can understand that in this simulation, you used as a climate driver, greenhouse gas only is there. So what you are going to understand is that this much changes happened only due to greenhouse gas. From 3, you can assume that this much changes happened only due to aerosols. And the second experiment is called historical natural experiment. Here the from word natural itself is clear. There is only natural variabilities included. So there is no anthropogenic variabilities included. So that means the man-made aerosols or man-made greenhouse gas is not there in this natural experiment. The first experiment is a combination of these 3 and 4, or 2, 3, and 4, we can say that. So that means natural aerosols, natural greenhouse gases, natural aerosols, everything is there. Man-made aerosols, man-made greenhouse gas, everything is there. Man-made greenhouse gases, everything is there. So that means this is a combination of, the first one is a combination of 2, 3, and 4. So that's how, so now you just think in this experiment, you have everything. Greenhouse gas is there, aerosol is there, land use land cover is there. And second experiment, you don't have anything. You have just natural variability. So if you compare these two experiments, experiment 1 and experiment 2, what we can say is that this much change in a particular quantity, let it be temperature or let it be rainfall, we can clearly say that this is happened due to anthropogenic contribution. And if you use the experiment 3 and experiment 4, you can one more level of uncertainty you can solve. You can clearly say that this much changes just happened due to aerosol. From the 4th experiment, you can say that this much changes only happen due to greenhouse gas. So that's how we are just making the statement this much changes are happened due to human induced or anthropogenic factors are responsible. The 5th experiment is most important, future scenarios. I told you that if I want to run my climate model, I need these climate drivers. So till 2022, we have this data, this aerosol data, this greenhouse gas data, everything I have available. So you may be thinking that how we will be making this data for future? I don't have a data, so what should I do? So there comes this this term called scenarios. That is basically popularly known as future scenarios. And there are many kind of scenario. This is shared, just forget that word, but you can keep in your mind that future, till so far, till 2022, we can say that this is the greenhouse gas value. So you have only one value, or you have only one aerosol value. But in future, nobody can say that how much, this is the only one value you have to take. So what we will be doing is that we will make different possibilities, okay? That is called different pathways. So if the world is evolving one pathway, this will be the aerosol and greenhouse gas concentration. So what it is doing is that simply, if I can summarize you for a quick instance, economy is coming into picture now, economics, socio-economics. A word here is mentioned is that socio-economic. So that means, just imagine our country, if it is growing at a rate of 7%, our people will be richer. So what will happen? People will be consuming more consumer goods. So that means a lot of industry has to work 7% more in an average sense. So that means a lot of production is required. So if produced like that, a lot of emission will happen. If our people will become richer, they will buy bikes, they will buy car. So our fossil fuel consumption will be.
So the reduction of poverty is the increase in pollution.
You cannot generalize that way. So if you reduce poverty, there are some other good things also. So for example, if the people are become rich, they can even think about solar energy, costly energy they can use. Correct? Yeah. So there is good things and bad things. So in general, if yeah. So in general, you can, what it is doing is that this economic information using certain other thing, integrated assessment model, that is a separate modeling group. So that just imagine like that, this economical information is converting into, as I mentioned, if we become richer, more and more fossil fuel emission will be there. That assumption is converting into the carbon dioxide. What my model is able to, my model may not be able to understand this economics. My model need carbon dioxide concentration value, aerosol concentration value, land use land cover value. All these values only I want. I don't understand economics. So I want this information. So this economic parameters is converting into this concentration of aerosols and greenhouse gases. So here comes the different possibilities. We cannot say that, nobody can say that this much is the carbon dioxide value, this much is the aerosol value, like that. So what the scientists will do is that they will create different possibilities. So that you might have heard that low emission scenario, moderate emission scenario, high emission scenario. Suppose we all are understood that climate change is a serious issue. We have to act on it. So a lot of meetings happen. So we all agree that okay, we should reduce the coal-based energy production. So all those things we are ready. Everyone in the world is give this as a top priority. And then we can do that. Everybody will be cutting down the carbon dioxide concentration in the atmosphere. So we can reach a low emission scenario. We can maintain a low emission scenario. But this is not a simple thing. India is also committed by 2070 only we will achieve a carbon neutral stage. So that means till then also we will be producing carbon dioxide. So because developed countries, they can even in a faster way they can impose all these things, but in developing countries they cannot impose these things strictly or in a faster way. They cannot implement, because it will affect their growth and necessaries of the basic requirements of people. So what we will do is that there will be a moderate possibility. Okay, you produce this much using, but you try to reduce. Okay, just like a agreement, mutual agreement. So there will be a moderate scenario. Some country will say that, oh no, I'm not ready to follow anything, any rule. I will go like whatever way I want, like that. Some countries may respond in that way. They will have a high emission scenario. So you can say that considering these different possibilities, scientists will design low emission scenario, moderate emission scenario, and high emission scenario. So then a different modeling group will convert that into concentration of greenhouse gas, aerosol, land use and cover change. Then I will take. So this international bodies will make available for researchers, and I will take that and I will run my model. So future I will be getting, instead of one value for everything, I will be getting these possibilities. If low emission scenario countries are followed, this will be your answer. This will be your temperature. This will be your rainfall. If moderate I am following, this will be your temperature. This will be your precipitation. This will be your rainfall. If high emission scenario, you are going to head up with extreme rainfall. You are going to have a lot of heat waves. So you are going to witness like that. So IPCC report is a collection of these possibilities. These possibilities, they will put forth in front of governments. So government also cannot act on this. So we will be naturally trying to reduce this concentration of greenhouse gases, and we will try to implement certain possible measures. So that is what basically happening. So these are all the different runs what you can expect from a climate model. So simply, this is the temperature from the climate model. Sorry, this is in Fahrenheit dimension. So the black is observation. So just you know that 1 degree, just forget about this magnitude. Just you can assume that from 1900 to 2000 or 2010, if you consider, we have a 1 degree warming. So this pink shade is the line from the run what I mentioned, this historical run, the first run, where you have the anthropogenic greenhouse gas and all those emissions. You have a line like this, and your temperature will be somewhat like this. So it's very close to observation. If you have only natural variabilities, that is what it's saying by this blue line. Okay, your temperature would not have warmed like this, or you would have been a 1 degree cooler state. So you can clearly say that human intervention is created this much increase in temperature. So that's how using the climate model, people are clearly saying how much temperature change happened due to greenhouse gas, aerosol, or man-made. In general, man-made interventions create this much change. So that's why. So I'm designing experiment. From that experiment, I am taking each and every parameters. If I take temperature, I will get temperature, what is going to happen. The same thing, if I take rainfall, we can say that it may be increasing, it may be decreasing. So if it is increasing, we can say that human intervention is increasing rainfall. If it is decreasing, we can say that human intervention is decreasing rainfall. So that's the way we are just addressing this. This I'm not taking complicatedly. You can see that this is the special runs what I mentioned. If you run only with the greenhouse gas, and if you run only with aerosol. If you run your model only with aerosol, the temperature would have been somewhere here. And if you run the model only with greenhouse gas, your temperature would have here. So basically, you can just assume this as a tug of war between aerosol and greenhouse. Aerosol is trying to cool the atmosphere, and greenhouse gas is trying to warm the atmosphere. So your actual field, the observation is the reality. It is somewhere here. So it is somewhere in between, just like a byproduct of who is going to win. If greenhouse gas is dominating, you will be moving towards this side. So that is what is basically happening. So just keep in your mind that whatever you witnessed is just like a tug of war between this aerosol. Aerosol was trying to cool this atmosphere, and the greenhouse gas is trying to warm this atmosphere. So, and your actual value will be somewhere in between who is going to win. So that is from that. So this is a So this is something just like a temperature. This is a different possibilities. SSP is, you can consider this as a low emission scenario. The left value, the left graph, The second one is a moderate emission scenario. The third one is a high emission scenario. The last one, SSP5 mentioned, is that a very high emission scenario. And what it is going to show is that with respect to 1950 value, how much our temperature is changed. Mean global temperature is changed till 2100. Again, you can see that the bluish shades are at lower temperature comparing to 1950. Sorry, here the mean value is in 1980 and 2010. With respect to this period, how was your temperature? Here you are in 2020. You can see that you are in the warmer side already. Already you are 1 degree warm, 2 degree or 3 degree warmer everywhere. And now you can see that 2050s, 2060s, the temperature is further increasing. You are becoming going to reddish shade. You are becoming red. Now, yeah, it is 2000, 2100. We can just pause here and just compare the first, second, third, and fourth. So this is the possibility. You can see that the first map is the low emission scenario. These are the climate scientists are telling that if you are following this, we will be ending up with something like this yellow. If you compare something like 1 degree or 2 degree warming, you will be reaching. In second map, if you follow, the reddish shades are slightly more. That means you are a moderate scenario. That means your carbon dioxide value is slightly higher. So you will be ending up with a 3 degree or 4 degree warming. Just focus over a region, India, and just compare with that color bar. Color bar is giving in degrees centigrade. So this much degree centigrade. So if you are going towards right side, this is SSP3 is a high emission scenario, and SSP5, you can see that it's turned to maroonish shade. And if you are following this high emission scenario, by end of 21st century, you will be warming by around 7 degrees centigrade or 8 degrees centigrade, or at least over Indian region. Polar region, you can see that it will be in a faster, it will be much dark in color. So these are all the different possibilities. So this is basically the climate scientists are posing or giving to us as an information through the IPCC report to the governments. And then you can imagine that now itself we are getting a lot of heat waves, a lot of catastrophes, a lot of heavy rainfall and all those things. Then you imagine if you are following this scenario, this last scenario, that means if you are like this, in today's rate, if you emit this carbon dioxide, will you be able to live in this country? It may not be, life may be almost impossible. Just see over Middle East, Africa, and northern part of India, North Indian plains, life will be almost impossible. Then government also have to act something. So that is various measures they will be adopting. So this is till observation point. Earlier you may be seeing that only one temperature value only I saw. That is observation. From the observation only I show. This is the future. Future. The scientists are telling that different possibilities. Either you can live like this, or you can live like this. Either you can live in this left direction, or you can live in this right side. So or moderate. So mostly this moderate. The second map will be a most acceptable format. So okay, some developing countries can do something, and developed countries will be more and more cutting down their emission. But developing countries, India, China-like countries also have to contribute a lot. So we will be in a livable condition even in this century also. So that will be the most crucial thing which will be coming. So if you think in a broader sense, vehicular standards, I told you that we are increasing. Factory emissions will be, government are increasing a lot of imposing a lot of rules and regulations. So easily this industrial emission we can reduce. So this is, the left panel is showing that the aerosol concentration, that is the sulfate aerosol concentration, is increasing till 2000, and then it is decreasing, and it is sharply decreasing. So in future, we will be decreasing aerosol, but carbon dioxide has a problem. It can remain in the atmosphere up to 200 or 200 years or even more. So that means if you cutting down, if you stop the carbon dioxide emission also, still for next 200 or 400 years, that amount of carbon dioxide will be there in the atmosphere. So this is a serious issue. So even if you follow this moderate scenario, the carbon dioxide value is somewhere here. So here I mentioned the present value is something 412. By end of 21st century, we will be reaching 620 or something like that. There is huge difference. This can create huge change in, again, this red line is something like that high emission scenario. you just imagine the carbon dioxide value is something touching 1200. So if the present value is 400, almost 3 times we will be increasing. So if in a warmer, you know that the present value itself created 1 degree warming. So if it is increasing 3 times, you can expect the temperature also will be cascading effect on that. So that means aerosols are decreasing. Earlier, now you keep in your mind the old map what I mentioned. Aerosols are something try to cool the atmosphere. Now you see that aerosol is very, very less. So that means in the atmosphere, aerosol, that cooling effect is very, very less. So in your tug of war team, aerosol teams almost scoot. They told that, oh, sorry, we are leaving. So like that they told, and they just stopped the game. So aerosol is not in picture, but greenhouse gas is still going up. So you can expect our temperature is going to shoot up like anything in future. That will have a lot of impact. Naturally, if aerosols are something, I told you that if aerosols are there, it will cut down the solar radiation, so that naturally temperature will be less. It will reduce the evaporation. If evaporation is less, means less cloud and less rain. But in future, what is going to happen? Aerosols are also not there, but greenhouse gases are more. Okay, so there will be a multiple effect. No aerosol, but more greenhouse gas. So what is going to happen? More greenhouse gas means more greenhouse effect. So naturally, your temperature will be more, is going to increase. If more temperature, what is going to happen? More and more evaporation, more and more rainfall, and so you will be getting more rainfall. So this is again end of 21st century. How will be rainfall over Indian region? You just keep in your mind. So the greenish shades are if your rainfall is increasing, that region will be green. If your rainfall is decreasing, that will be this brownish shade will be there. So over India, you can see that it is slightly greenish, almost 10% increase you can expect. In the low emission scenario, in high emission scenario, it will be something like 20% increase you can expect. In high emission scenario, you can expect more temperature, more precipitation. So just keep in your mind that it's in global scale, it's not everywhere increasing. You can see that this is the Mediterranean or European region. This is the equatorial American region where you can expect huge droughts or rainfall. What you are going to receive in future will be very, 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 very less. So at some places, rainfall may be increasing. Some places, rainfall may be decreasing. So you will be able to witness this African region. You can see that huge amount of deficit rainfall you can experience. So some places, precipitation may increase. Some places, precipitation may decrease in future. So like that, if you are getting, as I mentioned, aerosol is less, greenhouse gas is more. Naturally, what is going to happen? More and more evaporation will be there. So atmosphere can, in a warmer atmosphere can hold more moisture. Okay, so if it is holding more and more moisture, at certain point it has to collapse. So naturally, what happened if you are we know that already in a warmer, we are in a warmer condition, and if the atmosphere is holding more moisture, at certain point it has to come down. So that's why you are experiencing more and more heavy rainfall. So this is a simple measure of heavy rainfall over this region. So if you see, this is going to be increasing. I think no need to prove that. In Kerala also, you are last couple of years you are experiencing huge amount of extreme type of rainfall events. So that is a impact effect of this greenhouse gas warming and aerosol, less aerosol condition. In such a condition, you can expect more and more evaporation. If evaporation is more, you can expect more and more cloud formation, and that can lead to extreme type of rainfall. So in future, also you can experience, so from the climate model, we can simply say that by near 2040 or something, more and more extreme type of precipitation is you can experience, especially over this Western Ghat region and southern Indian side, or more or less this blue shade is that a number of extreme events you can experience. So here, last year you might have experienced 3 or 4 events, but by end of 21st century, after 30 or 40 years, you will be going to experience more and more extreme events all over these regions. So that's what the climate models are trying. So just let us summarize here the main part. Basically, this as a take-home message, you just keep in your mind that the greenhouse gas is something like which is trying to warm the atmosphere, and these aerosols are something like cooling the atmosphere. This tug of war is basically this climate change, where it will be going, whether it's going to warm or whether it is going to cool. So naturally, you know that in future, greenhouse gas will be more. So the temperature is going to shoot up, and we are going to experience its consequence. And through this climate model simulation, at least we can say that the human activities are mostly causing this climate change. And so from that different experiment you keep in your mind, and we mentioned that how we are assessing all those things. Aerosol is creating this much, greenhouse gas is creating this much, combinedly this is creating this much. So, so through that climate model simulations, scientists are clearly mentioned that these changes are anthropogenic or man-made disasters. So that is the one part. Then increasing trend of extreme events is a complicated problem. That is also you can directly relate to increasing greenhouse gas emission. And the only way what we can say is that to limit the global warming, strong, rapid, and sustainable reduction of carbon dioxide, methane, and other greenhouse gas policies are very necessary. So that means we have to become more, we have to practice more green initiatives to tackle this issue. So there I will stop that first part. And just I want to brief this part also. So how you can, where you can study this Earth, atmosphere, and ocean sciences. I presume that most of you are maybe school kids, and after your +2, you can think about, you might have heard about a premier set of institutes called ICERs. ICER having Earth System Science program, at least in all the ICERs, ICER Trivandrum also planning to open these courses recently. They will be also starting. ICER Pune is having, ICER Mohali is having. So there you can induct after your +2. So there will be different national exam. You can participate in that exam, and if you succeeded, and there are many other exams also, KVPY, many exams are there. They have their own internal test, or JEE you can write. So after +2, you can think about ICER. ICER is giving BSMS, that is that 5-year integrated master's program. So after 3 years, you can select what you want. Either you can go to physics, or you can go to chemistry, you can go to biology, or you can come to earth science. So there is an option. In addition to that, there are the other programs are you have to get a degree. Basically, it should be in, ideally, preferably, it should be in mathematics or physics. You can have a degree, and then you can go for a postgraduate degree. In most of the other places I listed, Cochin University, where I studied, Cochin University has a MSc in atmospheric science, and they have an MSc program in oceanography also. So you can opt this. In addition to that, there are, if you do BTech also, then there are MTech programs. Even Cochin University has MTech program. IIT Delhi, IIT Bhubaneswar, then Indian Institute of Science has a Center for Atmospheric and Ocean Sciences, and then IIT Kharagpur has option. Then Andhra University is one of the oldest universities having this meteorology and atmospheric program. And then there is Hyderabad Central University, Rajasthan Central University. So there are many places where you can get this type of courses related to Earth atmospheric science. It can be MTech program, or it can be master's program. Then after master program, you have to think about doing a PhD degree. Basically, we need trained manpower. So that means basically after your master program, you have to try for a PhD degree, that is a doctoral degree. Then there are a lot of research institutes in India and abroad also. Means after masters, you can try for PhD, you can go abroad also. There is a lot of options are there. And in earth science, it's relatively easy because a small number of people only will come to this field. If you consider physics, the class will be, there will be many people will be competing. But in earth science, the number of competition will be very less, but number of opportunities are very high. Considering this huge requirement and huge impact of climate change, government will be giving more and more fundings. So that is a good opportunity. So where you will do research. So earlier I mentioned that where you have to get a master's degree, and then you have to do a research program. All these centers have research program also. All these universities, all these IITs, ICER, IISc, they are all having PhD options. So either you can stick there itself, or coming to this field, Ministry of Earth Science, that is my ministry. So where we have almost 10 institutes. So this is called India Meteorological Department. They provide a lot of research opportunity also. Then there is a NCM, National Center for Medium Range Weather Forecasting. The institute is situated at Delhi. They are the main motto is to develop weather models. Okay, what I mentioned is that we develop climate models, but the Delhi Institute, what I mentioned is that they develop weather models and do the weather forecasting. So there is also huge requirement is there, manpower requirement. Then we have a slight biological side, Center for Marine Living Resources and Ecology, that is in Kochi, CMLRE, the short form. So they need slightly biological side also, means ocean productivity, all those things. So those who are having biology background also join there for research. Then we have a National Seismology Center where they handle seismology. Then National Center for Coastal Research, basically is ocean, how tide gauge, how the sea level rise, all those things. Institute is in Chennai. Then there is a NCPR, that is a beautiful institute, NCPR. They do a lot of Antarctic and Arctic expeditions. It's a very challenging and thrilling institute. They do a lot of polar ocean expedition and all those things. You can go to. We have a station at Arctic, and so you can visit there. You can stay there. It will be a lot of experience you can gain through that. So that institute is situated at Goa. So there also you can do your research. There is a ocean institute is at INCO is named at Hyderabad. So there is that institute main. Earlier I mentioned you that the ocean of how we will collect ocean observations. So that is mainly their duty. And then of course we have IITM, this institute where I am working. So these institutes, all these institutes are very big institute with more than 150 scientists are working in that institute. More than 100 students will be there always. So these are all very big institute, and you will be getting easily. You can in a 3, 4, or 5 years you can achieve your PhD. And then there is a NIOT in Chennai. There is a National Institute of Ocean Technology. There is an institute in Trivandrum. We have a National Center for Earth Science Studies, another institute. So you can plan all these places for your research, and after research also you can go for postdoctoral research. There are a lot of opportunities in abroad, United States, Europe, Japan, anywhere you can go and you can do your postdoctoral research and then come back and join all these institute as a scientist or in academy as a faculty member. You can join, and apart from Ministry of Earth Science Institute, ISRO is an option. Space Physics Laboratory is there. Vikram Sarabhai Space Center, you all may be familiar. VSSC Trivandrum, they have a atmospheric research group called Space Physics Laboratory. There you can do research, and after that you can even think about joining there. Then Space Application Center is there. Physical, that is SAC Ahmedabad. Ahmedabad, ISRO has a center. It is called Space Application Center. Then there is another institute called Physical Research Laboratory, PRL. CSIR is Council of Science and Industrial Research. They have many institutes. In Bangalore, they have one institute there. These atmosphere and ocean sciences are there. Then Indian Air Force need a lot of trained meteorologists. You know that weather is very important for them, weather forecast and all those. So they have a dedicated wing of aviation meteorologists. So after completing your atmospheric science or meteorology degree, they have exams. They will be conducting exam, and easily you can induct into as an officer. You can join in Indian Air Force. Then DRDO, Defense Development Research Organization. DRDO has various laboratories. In Cochin, we have one institute called Naval Physical Oceanographic Laboratory, NPOL. So they also need a lot of atmospheric scientists and ocean researchers. So all these places, you can do your PhD work or research work, and after that you can even think about joining there. And apart from that, there are huge opportunities abroad because you know that, as I mentioned you, that America is making a lot of measurement. In India, you were seeing that observatories as very, very small observatory, but America has, because developing country, they have huge money and their funding is too high, and there will be a lot of research in all major universities, Caltech and Oxford, Cambridge, all the big named universities. Even smaller universities are also having research in this atmosphere, ocean related field. Apart from that, many of my colleagues were working in JPL. I mean, I also worked in Caltech and these laboratories. Then Meteo France, that is their IMD of France. America has National Oceanic and Atmospheric Administration. ECMWF, that is European Center for Medium Range Weather Forecasting. then Center for Ocean and Atmospheric Studies. So there are various opportunities in this field. So maybe after your master's degree or after your degree, even after your +2, you can think about this field. If you are interested, you can just make some idea about this institute and you can plan accordingly. So basically, the one thing is that this field is require a lot of research. Comparing to physics or chemistry or mathematics, this is a newborn science. It's a part of it's a applied mathematics and applied physics. So those who are good in physics and mathematics can easily shine in this field. So maybe you can all think future along with your physics interest. you can do a lot in this subject as well. So here I am stopping my long lecture. Sorry for I took a long time, I guess. So thank you very much. Yeah, just one point. Actually, in terms of rainfall, aerosol is an enemy. For example, the monsoon was declining for the last 50 years. That was mainly due to more aerosol in the atmosphere. So that means if more aerosol, cooling will happen. Cooling means evaporation less. So that means it's a friend of temperature in the sense, but it's an enemy to rainfall.
Yeah. So there is a balancing thing
Yeah,
that
yes,
it's a balancing, but it's also a factor. At the same time, greenhouse gas is also helping us in up to a certain extent for the precipitation. That's a thing, I think so. But we are fearing your IPCC model is that the simulation was very clear that we are what this Vinisha Umashankar mentioned in Glasgow that. You are not thinking about what would happen in 2050 like that. Most of the leaders will leave this world by this 2050, 60 like that, and she is thinking about what would happen after 2100 and that thought is so things. And when we started this program, this lecture in a very, very basic informations and you develop to the research mode. And finally, when you discuss this IPCC report and its gist of that, that little bit threatening and we are a little bit anxious. That anxiety should be there in our mind to do something to reduce this carbon footprint like that. And really, it was a good one, and we have recorded in these things, and this program is being YouTube channel, so it's a repository for all the students. Those who are, we could see only 30 or 35 now there, but it would be there for a long time. So we thank Dr. Sabin and his institute IITM for supporting us. That at the same time we have to mention NCPUR. Because Dr. Tampan Melot from NCPUR suggested this IITM for us and is continuously supporting, and we expect the same supporting system from IITM also, and Dr. Sabin and Roxy Matthew also supported us and with these things. And before we are going to this questions session, we have to get some more reflection from the eminent personalities here, and that session will be handled by K. Jairam, former Deputy Director ISRO, and followed by the Dr. Nikhil Mugand is there, Ingersoll sir is there, Bhatt sir is there, and after that we will continue this question and answer session. And first I invite Jairam sir to.
Thank you, Shajil. Kekamo.
Yes, sir. Yes, sir.
Okay, and bandwidth issues under, so I'll be audible only.
Yeah.
Thanks once again. Shajil has thanked. Thanks and congratulations, Dr. Sabin, for the excellent, well-structured and highly informative talk. In fact, I had for many doubts because in ISRO I had the good fortune of interfacing with IMD as a user. in formulating. That is way back in 1980s when we launched INSAT 1 series with the VHRR payload on board and all. That was the time when satellite was being brought into weather monitoring. So it was very informative, and you have taken us all through the entire domain of weather, climate change, then global warming, the man's contribution to global warming, a very clear perspective of climate change, and the importance of compliance with the emission norms, which will only sustain this life on this beautiful Mother Earth. It was very, very invigorating. Thank you once again for that. And I'm sure that our student community would have benefited in a large measure, because these type of information are very difficult to come by, and in such a structured and consolidated manner, and you have given out everything to us. So thankful once again. And I'm sure that many students would have been enthused and enthralled to and motivated into venturing into this exciting and challenging domain, because you have given out the list of the organizations and the laboratories which they can pursue. And I don't want to take much time, but as a person from ISRO and as a person who was associated with IMD from the beginning, 1980 to almost to 2018 when I came out of the department, I just wanted to have a small question which has been bothering me, and I will ask it. See, from the conventional ground-based, sensor-based observations to the satellite observation integrated scenario, right from early 80s to 2022, we are today. What is the order of improvement in the modeling accuracy and the consequent prediction precisions? That is what I am bothered, because how satellites have supplemented your efforts and how close you are to the modeling and what it has brought the impact into your predictions.
Yes. Yeah, that is a very, very, very important question, sir. Yeah, thanks for all the comments. And yeah, this is maybe if you think about the satellite era, which is happened after 1980s, a lot of information came as a bonus to meteorology and weather services. What we are doing is that ISRO has a lot of satellites now. Even earlier, we were getting just like photographs, so something like that. Just like we are getting the picture of clouds, and we have to make the assessment about the depth of the clouds, and then you are using that information into forecast for the next day what is going to happen. But now what is mostly happening is that even satellites are able to give the vertical profile of moisture and temperature. So that is a revolution in the field of from the or gift from the satellite community to the meteorology community. So now what we are going to do is that there is a separate field called data assimilation. So all these data is assimilating into the modeling framework. And so that means if there is a sparsity in data over a particular, for example, if you think about Rajasthan or Himalayan region, it's a tough terrain and we will not be able to get measurements there. So all over the places, we will be using this satellite information, and we were incorporating all those information into the model. And that is remarkably improved the weather forecasting in a broad sense. You can say that a multifold improvement in weather forecasting is happened due to this satellite data assimilation. So you maybe, if you are thinking something like that, our cyclone forecast and all those things are really accurate nowadays. Earlier, 10,000 people were dying just like a cyclone with Orissa super cyclone or something, but our casualties are very, very less now. So in terms of improvement in weather forecasting, the contribution of ISRO is remarkable. Or in general, we can say that the satellite data revolution, what is happened from 1980 is contributing a lot in this weather forecasting.
Thank you very much. Thank you very much.
Yes, sir. If we were like the question I asked before. What did you say?
Yes, sir, yes. Hello, sir. Can I move on to the questions?
Yeah, please.
Okay, sir. In chat window, we didn't get that much of questions because a few of them were asking in between the sessions.
Yeah.
And I noted one question which is asked by Niranjan K. Manoj. So, what are the fresh new hopes for a generation like us from the COP26 Glasgow?
Yeah, I think nowhere in, because the meeting which was happened in Glasgow was COP26. So that means before that 25 meetings happened. In nowhere in our history that much commitments were never happened. Maybe Paris Agreement was an exemption. In that treaty, the world leaders decided to make we should limit the warming at least within 2 degree or 1.5 or 2 degree limit. But after that, in this Glasgow, we took a lot of strong steps. If you remember my that first slide, our Prime Minister committed that we will be, I don't know it's visible or not, India is committed to reduce the carbon emission by 1 billion tons by 2030, and within a decade we will be reduce our carbon intensity into something less than 45%, and by 2070 we are promised to achieve some net zero carbon emission. So these are all certain tough commitments, which has a lot of economical require a lot of economical impact, which will have a lot of economical impact, because it can somehow it may slow down our economy also. So that since a small developing country like India also committing this much strong way to adapt this climate. So as a result, you can see that many electrical vehicles are increasing. A lot of solar based or wind based energy production is happening in our country. So government is keeping all this in mind. Government want to go for a green energy revolution in our country. So these things are will give a good hope, I think. Especially, I will rate this Glasgow meeting was a great success. Even in its implementation stage, there were a lot of confusion. Also, some countries may not sign. You may imagine that Kyoto Protocol and all those things. There are some countries who even not signed in Kyoto Protocol. But so at least we are committed to do this, and Government of India is very eager to implement this. So that all together we can expect at least if we can tackle this 1.5 degree limit, that will be a remarkable achievement, I guess.
Yes, sir. Thank you, sir. Sir, no other questions were there in the chat window, but I have a general question, which I think that should be asked as a representative of all the other students. And it means even the Science Day celebration of 2022, it has a theme of integrated approach to science and technology for a sustainable future. That kind of a theme. And so what are the steps, or what should be the aim for the next generation, or my generation of the group of students that presented here, that we should take to create an environment, a sustainable environment, or balancing the ecosystem like that. More than the activities, or more than the steps you mentioned in the presentation, what are the other things and improvements in science and technology that we should be concentrated on?
Yeah, the simple answer is go green. How much green initiatives, whatever in all possible way we can adopt, we should adopt all those things. Reduce, reuse, recycle, starting from all those point of view, give weightage to more electrical green energy initiatives. So in all sense, we should able to use the new technology. Basically, if you follow these COP meetings, especially the COP25 what I attended, the main negotiation is that we need technology transfer. For example, the country like India, if we try to implement all these things, there will be a lot of economical implications. So for that, the technology is the only solution. The developing country, the countries like Germany, USA, they all have new energy efficient techniques. So the main debate what is happening in this meeting is that they have to transfer this technology to the developing country. So then these developing countries can also easily transform. So for example, if you think the vehicular standards in India is changing drastically from Bharat stage 4 to Bharat stage 6. So that means that is huge economical burden to Indian companies. So, but if we get this technology in a reduced rate manner or in a free of cost manner from a foreign company, and then if we implement that in our country, then the economical implication will be slightly less. So that type of so using all type of newly emerging technology and green initiatives, whatever possible way, we should try to adopt, and we should try to plan our activities accordingly. Then our future will be better.
Sure, sir. We all of us will try to do that with Go Green, and we will try to make the environment better for a sustainable future. So that were the questions selected. And before handing on the mic to Shajil sir, I just want to mention one more thing, that we'll have a feedback form for all the participants who have attended this program. We'll send the link in the chat window. I have just sent it in the chat window. So you can access the feedback form through that link. And please let us know how to improve our sessions and all that things. And also, after the vote of thanks, at the time of vote of thanks, we will post a link regarding the quiz corresponding to this webinar session. So all of you are requested to attend the quiz competition, and there will be prizes for the winners. And the result of last quiz will be announced just after this webinar through the social media handles and WhatsApp groups of UL Space Club. So all of you are once again requested to fill the feedback form. Shelsa. Yes.
Hi, can you hear me? Hi, Sabin. It was a nice talk. It was nice to see how you started with simple concepts like weather and the difference between weather and climate, and then finally moved to how we do the sophisticated modeling. It was also great that you highlighted the different research opportunities, like students can and work after they do their studies. I just had one question, or rather, comments.
Yes, please.
I just wanted to know your comments on the impact of Kyoto Protocol, because we had started this initiative in 90s where various countries had agreed to change their policies and so that they could tackle global warming and CO2 emissions. And it's like 20 years since then. So I just wanted to know your reflections on how it really turned out and was it really impactful? And that's it. And then, thanks again for your nice talk.
Yeah, thanks. Yeah, actually, in fact, Kyoto Protocol we have to admit that there is a huge success, but there are still some countries. So if you monitor these meetings, mostly this is something like that. This energy producing countries, for example, the oil producing countries are mainly opposing those things. OPEC countries, we can say that. So because if you want to implement all those things, it will be having a lot of problem for their oil productions. So apart from them, majority of the countries, most of the countries are ready to accept it and ready to conceive this and go ahead with the help of all the new technologies, and in all the possible way they want to implement this. But in last decade, some huge thrust of development, especially China and developing countries, were mostly not much bothered about all those implications. But now the signs are mostly clearly saying that this much impact will be there. So now, even after Paris Agreement, all the governments are mostly ready to accept these things. So this is just like a gradual procedure. Even from Kyoto Protocol, we reached at a stage that now, even apart from different politics and from regional identity, the politicians or the world leaders are come up with a good set of mind, and we have to tackle this issue in some way. So in that sense, we can say that Kyoto Protocol is something near to a successful end. It's at least at that stage, people started to implement it, and now it is something like coming into practice. Yeah, that way we have to appreciate that efforts.
Okay, great to know that. Thanks again.
Yes.
Shil sir, Padmanabhan sir and Nikhil sir is here. Padmanabhan sir. You are muted, sir.
Dr. Sabin, I have been telling that instead of looking at the space and the outer space, we should look down upon the earth itself. And you have provided the first chance for the students to look towards the Mother Earth and the atmospheric modeling and collecting data of the future as well as the past. You know, our students in the group are talking about the exoplanets and, the space events that might have happened millions and millions of light years back, where those events might have happened and died. Now I told them, you look towards Mother Earth. Okay. So if we use mathematical modeling and the data that we have, you have provided a mathematical model and the need to process the data. We can walk back 200 million years back and see how on our Mother Earth life emerged. I cannot say it cannot be possible. So you have given a very good atmosphere and a scenario for the students to jump into the field to do research in atmospheric field. And I have a request at this time, Dr. Sabin. You must provide enough facilities and data for research. I have been working associated with ISRO with processing measurements of atmospheric data. One is on INSAT 2A VHRR data, and then developing the entire software package for processing the Doppler weather radar manufactured by Bharat Electronics and IMD is using it.
Yes.
First thing is, the data should be made available to the research institutions and the students. I had a very bad experience of getting the data from IMD and other government organizations to put into the model and derive. You know what is model and you know why it is importance of data differential equations. This data was not available when I started it. So I will say 1 minute. In 1992, I was supposed to process the VHRR data. Jairam may be listening. To tell whether the two pictures taken over 30 minutes apart, they are looking at the same place, within 30 kilometers of fixed resolution, for which I wanted IMD to give me 1 full day of data. I was a member of the evaluation team and chairman was IMD Director General. I'm telling the experience, but the scenario may be different, I am sure. But this is important. So when I asked for 1 day data, the Director General, who was the chairman, he looked around and said, "Why should I give my data to others? Who is the other man? I am an ISR or scientist. He is sitting at the other end to prove that, sir, your camera is looking at the same place." But luckily, our Rangarajan was, the MCF director at that time. I told him, Papan, I am called Papan also. Papan, don't worry, I will give you how much such data as I did. I collected data from MCM instead of IMD, Delhi. I processed it and told IMD, look here, sir, the camera is looking at the same place every 30 minutes. But I was happy to listen. I was invited to the inaugural session of the National Institute of Ocean Technology by Dr. Thambi, who was the director of IITM Chennai. As a member of the radar processing team, I was invited. And chairman of that committee was the Deputy Director General of IIT Chennai. And I was so happy to listen to him that, sir, we are here to give any more data to anybody for research. That's a very great statement. Salute it. But I had another problem. When I process meteorology data from weather radar, there is a polarimeter radar, you know me very well. I was the only man who wrote the software to process rainfall from that. And we had to prove that the rainfall we have estimated from the radar, the 120 kilometer radius, needs to be correct. How do we do that? The students watch. We have a lot of research problems here. How do we do that? I calculate the rain from the radar. I ask IMD data to give me the rainfall. Okay. Rainfall, which they have measured over 1 full year. I have to pay money for that. They gave me. Why don't you make the rainfall data available in the website? The students take it and do research on it. We will get much more value from the research than getting 2,500 rupees for one pack of data. So I suggest that all research students, I mean institutions, IITM, I had come to IITM to present a paper on calculating exact rainfall using polarimetry radar. You know polarimetry radar?
Yes.
I have matched rainfall estimate from rain radar, matching entire rainfall recorded by India Material over 3 seasons over entire Kerala. So this means you can use the radar to measure rainfall accurately. But let me tell you, Sabin, even today there is a tendency for us to import the radar and the software from abroad.
Okay. Yes.
You know that there are certain Chinese radars sitting over India. They wanted one radar to be implemented on the Bombay over the naval base. They objected, saying that we don't collect Chinese radar to put our footage. So that is where the Bell radar went there. Why are we insisting on Chinese radar to match our radar? Why are we, we process, I have the head of the department which calculate the orbit of the satellite, which we took satellite to Mars at 1 kilometer. I gave a presentation in Calicut. Professor U.R. Rao was my boss, was under terrible pressure to import software for satellite orbit calculation. He said, no, I will not do it. My boss will do it. That Moise developed the software to calculate the entire orbit related software for mission planning, operation, analysis, and control of software. He took it to Mars, 7 crore kilometers away. If Professor Rao had imported the software, you would have been importing even today the software. So what I tell you, sir, Sabin, sir, you must take a hand in saying that let us make the software here. Let our boys do that. My brother's daughter passed out in MSc Meteorology from Calicut, Cochin University in first round. She has no job. She's first round. She got no job. So who will jump into this wagon? So I thought there should be facility. I'm telling the experience. So there should be open mind by all involved in hardware and software and in planning to open up the gates for research, development. And that is my input. And students also should say that there is a big... You have to tell the student. You told them these are all the institutes where we can do research. You must also tell them where they can get a job.
Yeah. Thank you, sir. Thank you very much for this. A lot of you
can go to JPL. No. In 2000, I was with a set of applications asking for a job in ISRO and work on radar. You know what was the result of that? I got some first-rank students, PhDs, who are passed out from Kerala Indian universities who are working in Korea, Netherlands, Germany, JPL. Those applications I got from Indians were below 40% mark. Nobody was willing to stay in India and do research on atmospheric sciences. Why is that? My friend, Mr. G. Vishwanathan is the weather radar man. I was with him in Germany in 1980. We was working with the German scientist, Dr. Putt. He said, we asked him, Dr. Putt, how are you making your radar class of? He said, I will make a radar and give to my company, to my customer. He will operate. He will give me the data. He will say, Putt, this is the problem with your radar. Then we work together. That my user and the developer, they work together. They improve. In India, it is the situation is different. If I give a product and give a small failure, forget about that important. We have achieved this today because of our continuous effort. So, sorry, Sabin, you have to open up. Okay? Yeah. Believe in Indian. I am very happy that you have opened up. Believe Indian. We can develop it. We can model our atmosphere. Yes. I tell you, there is a book, Expedition in the Himalayas, where the European team, they went ahead and came back and don't go further. Why? I got a message in my mobile saying that there are going to be severe ice fall. Where did you get? I got it from Hong Kong. Hong Kong predicts the weather over our Himalayan region. What about the China is going to do with that? Weather is a part of is an important part for warfare, isn't it? Yeah. We should explore our weather ourselves. We cannot import weather. We cannot import climate. This is my message. Thank you.
Yeah, thank you, sir. Thank you for the valuable points. So in terms of data delivery, there was huge issues earlier we were facing. Even in between MOES institutions were very difficult to collect the data from our sister institutes. But a few years back, the Ministry of Earth Science changed its entire data policy. So now for all the research purpose with the meteorological and oceanographical data, anyone can access free of cost. And there is a dedicated data center in IMD. So any institute can easily register there. It's just a one-time job. Just like we are accessing a foreign satellite data. So just like they can one-time register and they can request for the data. And immediately, even the classified data also, they will be giving on research purpose. That's a major development happened when in the couple of years.
Put them into the website.
Yes. So
I know there was a scientist who wanted to model our atmosphere, and he had developed software that was not available to fit in his product.
Yes. Now that is changed. I don't know, that may be part of some Indian mindset, but now that's completely changed, sir. So easily we can get the data.
You know who was the chairman of your department when this decision was taken to give the data? Dr. P.S. Goyal. He was my boss. He was my boss in ISRO, and he is my neighbor here, 2 houses away. He told me about it. He is an open-minded man.
Yeah. So those time it was I am taking some huge effort to collect this data, and then why should I share? So that was the mindset. But now that is completely changed. And
data is collected over with our taxpayers' money. Give it back to them.
Yes. Now, anyway, the MOES has a data policy and which is open to all.
Thank you very much. It should be done.
Yes.
And fund research. Give money for and give them projects. This project for you, please.
Yeah, as we have a huge support for national project called National Monsoon Mission, through which we gave a lot of support to universities to pursue research. So it was a huge effort, and governments gave a lot of money to improve the monsoon prediction in country. The program is called National Monsoon Mission. So at that time, U.R. Rao sir was our GC chairman. So at that time, these projects were implemented in IITM. So basically, IITM is handled that, and we gave a lot of money for basic research, especially to Indian universities. Even foreign universities also we considered at that time. So, but majority of the money given to Indian universities.
And we should thank Sajil sir. We should thank, Sabin, you are from Kerala, right?
Yes, sir, yes.
And we should thank three Malayalis for a wonderful research in this. One is Anna Mani.
Yes.
Dr. Anna Mani. Professor P.R. Pisharodi, who was the Director General of IMD.
Yes.
And our Madhavan Nair, who was ISRO chairman, who took initiative to make weather radars in India, first weather radars. Yes. Isn't it? He only initiated that. We should be very, very thankful to you. Okay, thank you.
Yeah, thank you very much, sir.
Good evening, warm good evening, Professor Sabin.
Yes, sir.
It was an excellent talk. While as a science it is so exciting and then a lot of opportunities are there. As a pure theoretical area and very complex area, you have put it very lucid and make the children look into this area even as a life learning subject. But as a social subject, at least your talk should make the children feel that the threat of global warming is real and it is there. Two dimensions of your talk. It makes us all believe that it is a real threat and what we are going to do about it. Science is okay, we can do research and all that. What our future generations are going to face is a big threat hanging on the humanity that we are not even realized. The whole of the humanity has not realized that we are going through a slow crisis. We are walking towards a loop of crisis. That education should go to the public. That is one thing which we are all, we should make it happen. That we are all walking towards a trap. I don't think anybody has realized this particular aspect of it. While science is exciting, fine. But what about the threat and how we have realized it? How far we know that we are into a threat? That education should come from Professor Sabin like people, I think. That's my sincere request.
Yeah.
Thank you.
Yeah, thanks, sir. Thanks for the comment. That is very important. So actually, we have the institutions like ISRO and IITM. So we have limitation to communicate to public. But these are all the forums. So that's why I really appreciate your effort in which we can interact with kids especially. So the only way is that the message should reach them, and then they also should take it up. So then only we can go ahead and do some wonderful in this field. Yeah, that's very important message, sir. Thank you. Thank you for pointing out that.
Shajil.
Sure, definitely. Definitely, definitely. Yeah.
Yes, sir.
No. We had a wonderful session, Shajil. Let us. Now it's almost time, and the 2 hours have just gone, and we have never realized that it is 2 hours plus. So let us.
I'm sorry, I took a long time.
No. It's nothing to be sorry about that. We never knew that 2 hours have passed actually.
Yeah.
So anyway, the good things have to come to an end. We are sorry about that rather. Okay, Shajil, let us close.
Shall sir? Shall sir, before going to Shreya, sir, I want to make the announcement of quiz. That our quiz competition link has been posted in the chat window. So students can access the quiz competition through that link. And once again, I request all of you to fill the feedback form. And I have another request that is to all the experts presented here. Like Jairam sir said at the earlier part of our webinar session, we are doing a work on an e-magazine, which is named as Stellar Chronicle. So I request our experts to give us your contributions to for our magazine. It will be a blessing for all the students behind the Stellar Chronicle magazine. So I request all of you to give your contribution for our magazine. And that would be really gladful for us, sir. Shall sir?
Today, we had a great session led by Sabin sir. Sir, you gave us an idea about the scientific reasons behind the climate change and different approaches towards it. And also, you gave us an idea about the institutes which offers master's degrees and research opportunities in this particular area. And yes, this topic is always relevant to us because when we look into last few years, Kerala is a place which facing such a drastic climate change. So this topic is always relevant to each one of us. And I would like to take this opportunity to thank you, sir, for giving us such an informative session. And also, I would like to take this opportunity to thank our mentors and all our delegates for their constant support, and as well as all our students and members who gathered here for their active participation and interaction. Thank you, sir. Thank you all.
Yeah, definitely. Yeah. Thank you.
Thank you.